So today I'm here to tell you a little bit about string art and how it's related to math. I've replicated a string art, sort of, not really string art, but the idea behind it on this page. And you can see, for example, the dots would be where you would pound some nails into a piece of wood or some kind of a substrate. And the lines would be where you could connect pieces of string. And the string is only going to be able to connect in straight lines. The string itself won't curve because you have to hold it tight, and it just doesn't work if you let it be loose. And if it's tight, it has to make a straight line, right? So string art is kind of based on the same idea as this drawing that I've made on my paper, where we have all these straight lines that when they fit together, they kind of make this interesting curve here. And it's really interesting because it's made out of only straight lines. Well, how does that work? Well, let's kind of go through and see if we can make it out, make our own as we go through this. And what I have here is your grid or your Cartesian coordinate system. And I've marked some points on here that we're going to use as our nails or our fixed points. And we're going to go through and just connect a couple of points and see what happens. Now I want to prove to you that these are straight lines, so I've got a fancy ruler, very fancy, and I'm going to connect my dots right there. Got a straight line. Y equals mx plus b, just straight from your algebra class. You know all about that. You could even calculate the slope here, couldn't you? And our very last point is going to be this one down here. If I did them in order, it would be the last one. It's the second one I'm doing right now. Okay. And you can see that I have two straight lines that intersect. And that doesn't look at all like the picture I showed you at the beginning. I don't have any curved lines going on there. But what we can see is that this line has a particular slope. It's a pretty steep slope. And this one has a much more shallow slope. It's closer to zero. This one is much bigger than that, or much more negative in this case. But what happens when we fill in those points in between, the ones that I skipped between the first one and the last one? So there's another line, and here's a third line, and here's a fourth line, and the sixth line, and finally the last one that I can make on this particular set of nails is right here. And you can see that with all those straight lines, we've actually got this curve forming here. And the reason that curve is forming is because the slope is changing very gradually. In fact, you can even calculate that slope, as I did on this page. You can see that the steepest slope was at a slope of -6, and it gradually went down until we had a slope of -0.16 repeating on this very last line that we drew. And so because the slope is changing so gradually all the way down, our mind is automatically interpreting that as a curve instead of a bunch of straight lines. That actually has some pretty big implications in geometry and all kinds of other math places. But for example, you could imagine that if this went all the way around, maybe you started with a closed figure like a square or something, you could make a perfect circle or an oval or an ellipse or something of that sort, even a hyperbola or a parabola, if you know what those things are. And that would happen because we have all these small changes in slope. You can also imagine that all these small changes in slope and all these shorter straight lines could eventually approximate a perfect circle or some other perfect circular or closed parabolic shape of some sort, conic section, whatever you want to create. So, and that would happen even more perfectly if you put these points closer together. In fact, as you make these nails closer and closer together, you're going to have such a perfect circle that eventually the only thing that would limit the amount, the circle itself and how wonderful and perfectly smooth that circle would be the nails themselves and how close you can put them together. This has all kinds of implications later on in math, and in particular, when you get into calculus. Calculus is often going to be talking about the limit as these gaps get closer and closer together, and what happens to the slope of that line as the gaps here or here get closer and closer together. There are all kinds of different changes and different variations that you can make on the same idea. For example, here's a simple variation. On this one, all I did was I made the axes, or where the lines where the nails were, not at perfect 90-degree angles. Here, they're at an acute angle, which creates a slightly different shape. And especially if you look back here at the lines and exactly what's going on with how the lines are intersecting, it just changes the shape a little bit more. I hope you enjoyed it. And I hope that it makes you think a little bit more as you look at different straight lines that you see and how all of the lines intersect and how math is really embedded into every piece of what you're doing in this project.